Hello my students, I hope that this video finds you well, and I hope that you all had a wonderful Easter break too. During this time of the coronavirus pandemic, one of the things that I've actually been enjoying doing is going out to the backyard and having a little bit of a campfire out there. And I was thinking, what a great topic to talk about in science class, because fire is something that we're all very familiar with, but very few of us actually know how it works. Lots of us have campfires or fireplaces or candles that we enjoy the warmth and beauty of, but very few of us actually know the science behind fire. So I thought that'd be a great lesson to give to you guys here. It doesn't really fit into, earth science or plants, which is what we've been studying this year, but we're mostly finished up with those topics, so I can do a few random topics for you guys now in the video lessons. So I hope that you will enjoy this, and at the end I'll even have a few experiments that you can potentially try at home if you have a parent's permission and supervision. But remember, fire can be very dangerous. As wonderful of a thing as it is, if it's misused, it can be very, very destructive. So keep that in mind as we talk about this. So, fire. The first question I have for you is, what is fire? When you think about the three states of matter, we tend to think of everything as either a solid, a liquid, or a gas, right? Or is it? So what would fire be? It's definitely not a solid. You can't pick up fire and throw it to somebody. It's not really a liquid. You can't pour fire out of a jar. But it's not really even a gas either. It's not something you can fill a balloon with or put in a jar and then open up later and bring out. So the question is, what is fire? If it's not one of these three states of matter, what is it? There's actually two other states of matter that are much, much less common. One is plasma, and the other is this weird sort of really cold solid. But it's not either of those either. So fire is not a solid, a liquid, or a gas. And that might confuse us. We think, well, what is it? It's a thing, isn't it? So it has to be made of matter. And fire isn't really made of matter per se. What fire is, it's actually a chemical reaction. And we're going to talk about what a chemical reaction here is shortly. But it's basically where you have substances changing from one substance into another. The fifth graders right now are learning about that in their chemistry class. And in chemical reactions, oftentimes energy can be released, and that's exactly what happens in combustion when you get fire. So fire is actually light and heat, so brightness and warmth that's released from a chemical reaction, and that's what fire actually is. Now, some background information to help us understand how fire works. We're going to talk about it in terms of wood. So we're going to pretend we're at a campfire, and we've got wood burning right now. So, wood is made of molecules that are stuck together. Now, molecules are just really, really, really tiny pieces of material. So you think of atoms are the smallest things. Molecules are just a little bit bigger than that. They're made of atoms. So in this diagram here, I have a block of wood, and if we look at it under a super, super high-power microscope, if we were to have one of those, we could see that there's all these individual dots kind of stuck together, and those are the atoms and molecules that are making up the wood. Now, in molecules, and I just taught this to the fifth grader, so if you have siblings there, you can ask them about this. With molecules, when you have atoms stuck together, there's energy required to stick them together. So it's kind of like energy is a glue that holds these little pieces together. So when you break apart those pieces, that energy that was holding them together is suddenly released, and it can come out in lots of different forms. And that could be a whole lesson in and of itself, the different forms of energy. Energy can come out in the form of motion, or sound, or light, or heat. And light and heat energy is the way it's released in fire. So that's what's going to be happening in fires. We have wood, and we're going to be breaking apart these molecules, and when that energy is released, it comes out in the form of light and heat. And that is why fire is bright, which you can see here, and warm, which you can't see, but I can feel. It's warm. So, in any fire, you're going to have three ingredients that are all required in order for it to actually work. The first ingredient is fuel. You can't just have fire just sitting here without anything that it's actually burning. When you have fire, something's actually burning it to make it happen, and that thing that is burning is the fuel. So, like in our cars, the actual fuel is fuel for a reaction that happens, a combustion reaction that happens in the engine. So there's actually little fires being made in the engine of a car. So that's where the fuel is there. Or in a campfire, the wood is the fuel. or in a candle, the wax is the fuel. So you always have to have some sort of fuel, something that is burnable. The second ingredient is, interestingly enough, oxygen, and that's the stuff that's in the air that we need to breathe. Oxygen is a certain type of element that makes up about 1/5 of the air, and it's actually very reactive, and it is what causes fire to actually keep burning, and so without it, you won't get any fire. So if you had air that didn't have oxygen in it, you couldn't have fire, which is very interesting. So that's the second ingredient. The third ingredient is ignition, or a source of heat. That's the same thing. So when you ignite something, like you ignite the engine, you're kind of putting sparks in there to get it to start to burn, or you ignite a fire, you might drop a match in there and ignite the kindling and paper that you have starting the fire. So ignition is just another way of saying like the heat that gets it started. And I have a nice little diagram here of the three ingredients. You have oxygen, heat, and your fuel. And you need all three of these in order for it to work. If you are missing one of these, like you might have oxygen and fuel, like you might have a nice piece of wood and you might have plenty of oxygen in the air, but unless you have some source of heat, it's not going to burn. Or you might have the heat and the fuel, but unless there's oxygen, it won't burn. Or you might have the oxygen and the heat, but unless you have a piece of wood to burn, you're not going to get anything burning. By the way, a side note, I don't know if any of you have had much practice with making fires before, but this oxygen part, that ingredient, is actually very important. So when you build your fires, you want to make sure that oxygen can get in. And that's why lots of times when you blow on a fire, it actually gets hotter because you're actually blowing oxygen into it. And that'll cause it to react faster and become hotter and brighter. So lots of fun things to do with that. Okay, so let's actually talk about how fire happens now. So the first thing that happens is that heat, that ignition source, it kind of loosens up the molecules in the fuel, which end up turning into gas. Now, if you remember that picture of the wood that I had earlier, where all those molecules stuck together, making up the wood, what happens is when things get hotter, they start to vibrate, so they start to shake a little bit. And when they shake enough, they actually kind of break free, and they go flying off into the air, and they become a gas at that point, so they become part of the air. And once these things get into the air, and they're called volatile gases, they react with the oxygen. They're able to react with the oxygen when they're in the air, and so when they then react with that oxygen, and that chemical reaction that happens causes light and heat to be released. And that's the energy that was making those molecules stick together. Now, when they're broken apart, that energy is released, and that comes out as light and heat energy. And that's what we know as fire. Now the interesting thing is, fire keeps burning. It doesn't just, it's not like you just use your lighter and you light a little piece of paper, it burns for 2 seconds, then it's done. It actually keeps going. And the reason for that is heat is one of the things that is produced by a combustion reaction, by burning. So heat is produced by fire, and heat also causes fire. Remember our triangle, heat is one of the sides of that triangle. So when fire makes heat, it actually makes one of the ingredients that it needs to keep itself going. And then it has more fuel, and it has more oxygen, so it keeps burning. So fire will continue burning as long as it continues to make enough heat, as long as it continues to have enough fuel, and as long as it continues to have a supply of oxygen from the air. The fire will keep going. So usually when a fire goes out, it's because one of these things has left. So maybe you pour water on it, and that stops all the oxygen from getting into the fire, and then it goes out. So that's how that happens. Actually, before we go there, a few just practical safety points for you, because fire safety is a very big thing. If you ever have a fire that you need to put out, think about ways to keep the oxygen from getting to it. So try to make it so it can't get air. So if you can put anything on top of it that will stop it from getting air, then that should put out the fire. So imagine I have a nice little fire that I dump my candle over and it catches one of my books here on fire. There's a lot of things I could do. I could get a fire extinguisher, which sprays this stuff onto it that stops the oxygen from getting to the fire, and it puts it out. Or I could also dump some water on it, and the water kind of covers it, and water doesn't burn, so that'll stop the oxygen from getting to it as well. A third option would be to throw something like dirt on it. If I can throw some sort of dirt or whatever, it actually kind of coats it and stops it from getting the oxygen it needs to burn. So as long as you can cover up a fire, you can usually put it out if you can cover it up well enough. So there's one piece of fire safety for you. Another piece of fire safety for you is if you ever find that you have caught on fire. So say I'm here teaching over my candle and I put my sleeve over the flame and it catches on fire. There's the classic 3-step thing of stop, drop, and roll. So lots of times you'll be told to actually stop whatever you're doing and just fall to the ground and roll around. And as you're rolling around on the ground, when you press, say my shoulder is on fire from the candle, when I press my shoulder into the ground, it actually takes away the supply of oxygen from that burning shirt, and then it goes out. So it kind of snuffs out the fire when you do that. You can think of that. Although also if there's like a swimming pool nearby, you might just want to jump in there. That might be a quicker way to put it out. But anyway, stop, drop, and roll is a great way to put out fires if you find yourself catching on fire, which hopefully none of you ever have that in your life. Okay, now that we've covered some fire safety, let's talk about a few fun experiments that you could do, though you do not have to do, and this is only if your parents give you permission and they are supervising you. So you have to ask them if it's okay and ask them to help you too, so that you don't accidentally catch your house on fire. I think they would be pretty upset if that happened. The two experiments that I thought of that we could do would be putting a candle inside a jar and lighting the smoke of a candle. Now actually, I guess both of these I could show you myself, but I just want you to think first. So I have a candle here in a jar, and I want you to think, what would happen if I were to put a lid on this jar? What would happen to that fire? Well, we can think in terms of the 3 things that a fire needs in order to keep burning. It needs its fuel, it needs oxygen, and it needs heat. Now, if I put a lid on here, it still has the heat, and it still has the fuel, but I cut off its supply of oxygen. It no longer has access to the air. And it'll burn for a little bit while longer while it's burning the oxygen inside the jar, but then it'll actually end up putting itself out. And actually, I think I have the lid over there. I'll go ahead and show you this experiment. I'll be right back. Alright, so I have the lid to my jar here, and what I can do is I can just go ahead and stick it on, and I will show you what happens to it. And you can try this at home as well. But I'll stick my lid on, and it's still burning, but then it just got darker and the candle went out, and now it's filling with smoke as well, and that'll lead us to the next experiment, the smoke part. So the other experiment that you can try is actually lighting the smoke of a candle after you blow it out. Now this one almost feels like magic, and I'm actually going to include a link to a YouTube video of somebody else doing this and filming it with a slow motion camera. So you can look in the homework notes for a link to that video. But basically what you do is you take a candle, so imagine this was still lit, and you blow it out, and then very quickly after you blow it out, you take a lighter and you light the smoke trail that's coming out of the wick of the candle. And what happens, and it almost seems like magic, is the candle relights. Even though you don't touch the fire back to the wick, it relights. And the reason that happens is the wick is still hot, and there's still lots of really hot wax right down in there. And what happens is, remember how we said that fire is those molecules in the wood or the fuel actually breaking loose and going into the air and reacting with the oxygen in the air? What ends up happening when you light the smoke trail is in that smoke trail there's lots of those molecules, and in this case it would be of wax, floating around in the air. And they're just waiting to be burned. They just need something hot enough to burn them. So when you introduce a new flame over there, over those molecules, they'll actually catch on fire, they'll ignite, and there's a little path of those molecules going back to the wick, and they'll burn and go all the way back to the wick, and then it'll catch on fire again. So sometimes you can relight a candle, like say this is my candle, I can relight it from way over here, as long as it has a nice trail of wax molecules to follow back to the wick. And this one's kind of hard to do on your own at home, but maybe a parent could help you, and if it doesn't work, that's fine, and you can go ahead and just watch the video of it being done as well, because the video you get to see it in slow motion, which is really cool. So anyways, that's all that I have for this video right now. If you do choose to do these experiments, please be sure that you are using an adult's supervision and permission with it. I don't want any of you to get in trouble by playing with fire when you shouldn't. Because remember, fire can be very dangerous, and it can burn people and ruin houses, and it can even kill people if you're not careful with it. So be sure to be very careful with the fire. And it's a wonderful gift if used wisely, and if you use it with lots of good safety precautions in order. But anyways, I hope you enjoyed this video. Lots of fun things to think about next time you see a fire, either in your fireplace or a candle or outside. It's a really neat science thing going on there. So anyways, I hope you enjoyed, and I'll see you next time.